Factor by GCF. We are factoring quadratics. GCF is greatest common factor. Oh, I guess I don't need factor because factor is already part of the stem. Okay, let's find the GCF of 5 and 10. So if you're really struggling with multiplication, if you have not done, if you're not good at multiplication, you can use the calculator for this. But what I want you to do to show your work, I don't want you to just put a number there. This is how I want you to show your work. We're going to look at 5 and we're going to look at 10. You're going to list out everything that multiplies to get 5. So 1 times 5. That's easy. And then we do 10. 1 times 10, 2 times 5. So then we look for the greatest factor they have in common, greatest common factor, which is 5. So circle it. And then write GCF equals 5. So on these simple ones, it's easy to write all the factors, no big deal. On the bigger numbers, it's going to take a little bit more, but we can still do it. So I'm going to do it like this so I have plenty of room. So 16, 24, and 80. So for 16, so each one you'll always do 1 times itself. And then you just look and see, does 2 go into 16? Yes. Does 3? No. And if you're not sure, just divide it. Take 16 divided by 3. And then 4. Start out with 1 times 24. It's even, so 2 times 12. If you're unsure, use your calculator to divide. 3, 4. Okay. Now do the same thing with 80. Go ahead and do that. Use your calculator. Write down all the factors of 80 right now. Are y'all ready? What's the next factor? 240. 420. 516. 810. And then we look for the greatest common one. Well, they have 2 in common. They have 4 in common. They have 8 in common. 16 and 80 both have 16, but 24 doesn't. So that means that the highest one that they have in common is 8. Okay. All right, so we are going to use the GCF to factor. To factor means you are going to undo multiplication. But what we're actually undoing when we factor, because we're dealing with variables and numbers, is we're undoing the distributive property. So I'm just going to put you are undoing distributing. So always in math, you learn how to do something, and then you learn how to undo it. Like, you learned how to add, and then you learned how to subtract, multiply, divide, square something, square root. Everything is undoing things, like learning how to do it and then undo it. Because you got to go both directions. So let's look at what distributing does. We multiply, right? So we multiply the coefficient, so 2 times 7. And then we add exponents. So x times x is x squared. And then you multiply 2x times 3. 2 times 3 is 6, and you keep the x. So that's distributing. So factoring is going back. It's going the other way. Yeah, basically you find what your GCF is and you divide everything by it. So we have a 3-step process here. Create a full factor list. Circle the largest common factor. And then same as number 2, step 2, but with variables. And then you rewrite with GCF out front. So rewrite with GCF in front of the parenthesis. So it's actually step 4. All right, we have 4 examples to do. So let's look at the first. I'm going to draw the line just like I did with GCF. And I'm going to do the numbers first. I'm going to list out all the factors of 21, all the factors of 3. So 1 times 21, 3 times 7. And then 3 is just 1 times 3. We're going to hold off on the negative just for a minute. And then you do the same thing with the variables. I have x squared. So I'm just going to break it apart. And all that means is x times x. And then the next term just has 1x. So we're going to circle the GCF. So 3 is our greatest common factor. And then we circle the same number of variables on both sides. So I have 1 on one side and 2 on the other. So the maximum I can circle is 1. So that means my GCF is what I circled, 3x. So I'm going to rewrite it with GCF out front, GCF. And then I have 2 terms. And I have a subtract between them. So it's going to look like that. So my GCF is 3x. And then I look at, well, what do I have to multiply 3 by to get that 21? 7. So I'm going to underline it in my list and underline the remaining x in my list. And that's what goes in that spot. And carry down the minus. And then we look at what is the other number that matched with my GCF. I'm going to underline it. And that's what goes in the other blank. So this is the factored form. So, all right, let's go to the next one. All right. Do it like that. Put the line behind the term, behind the exponent in front of the sign. There we go. Okay, what is it actually in front of this? 1, so it's just 1 times 1, right? How many x's do I put down at the bottom, though? The next one, I don't have any coefficients, so it's just 1 times 1. Put 4 x's. 1 times 1, and then the 3 x's, yeah. How many x's can I circle on each one? 3. That's the maximum. So circle them. I don't know why I do this, but I go backwards. I don't know. So then my GCF is, yeah, we just have 1. 1x, how many? Cubed, yeah. So on this one, I'm going to have my GCF out front, and then I have 3 spots I need to fill in the blank for. And I'm going to keep the sign, so this is subtract, and this is add. And this would be add.
My sausage office. Okay. One second, this is an interpreter. Let me. Okay.
Hello. Hey. Mm-hmm. Mm-hmm. Yeah. I'm in the middle of a lesson. Is there any way we could talk? Yeah, is there any way we could talk about this? Yeah. I have second period off. Okay, thanks. Bye. All right. So we can put 1x cubed, and then what's left? Yeah, 1, 1, 1. But then how many x's are left in that first blank? 1x squared minus, yeah, 1x plus just 1, yeah. Okay, but we could write this simpler. We could leave off these ones, but we would have to leave that last one. So you can leave it just like that and all good. Or you can change this to x cubed, x squared minus x plus 1. All I did was take out the ones that were coefficients. All right, let's go to the next one. All right, what multiplies to get 20? 120, 2 times 10, 4 times 5. And then we have x, but then we have 2 y's. So let's separate those. So that way we know that they're different. Okay, and then we have just 5. So 1 times 5. And then we have 2 x's and 1 y. So then our GCF is 5, an x, and a y. You have to make sure you can circle. If I had 2 x's, I would circle 2 x's on both, but I don't. I only have the lowest is x. The highest is 2 of them, but it has to be circled on both. So then my GCF is 5xy. So then we'll write it with our GCF out front. And then a blank minus blank. So 5xy. And then what do we have? Underline what's left over on each side, or what's the match with our GCF. So we would have 4y minus 1x which, let's go ahead and simplify that to just be 4y minus x. Okay, go ahead and start the next one. Example 6. But don't write the final solution yet, because there's something special, because there's a negative out front. Some of these numbers we've already done.
All of them.
I don't think we've done 12. No? But not a big deal, right?
I did it in my head.
All right, circle your GCF that's found in each column. So I know one of the x's. What's the number GCF?
Huh?
What's in common?
4.
Yeah, 4. So then GCF is 4x. All right, so the special thing here is with this negative out front. It's called our negative leading coefficient. So whenever that happens, you're going to factor out a negative. Factor out negative. And that's going to change all of the signs. So we're going to circle all of the signs. Anytime it's a negative leading coefficient. So it's going to be negative GCF. And then blank minus, because I'm switching. I'm going to switch these. Well, I'm switching all of them. And then minus blank, like that. You just switch all the signs. Flip them. Switch all signs. Whenever you factor out a negative, it switches all the signs across the board. So that means my GCF is going to be negative 4x, parenthesis. See how the first number is negative 12x to the 5th? Well, it's going to just be a positive, whatever is left. So look at what's left. 3, 1, 2, 3, 4. 3x to the 4. And then I'm switching signs, so minus 5x minus 4.